morning, everyone. I'm Anusha. I'm working as assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today, I have to discuss a video lecture on genetic algorithm. In that genetic algorithm, what are the course objectives? To understand the foundations of machine learning, including well-formed learning problems, concept methods, version space, decision tree learning. So different types of algorithms are there. So in that I'm taking genetic algorithm. So these all are the course outcomes. Understand supervised and unsupervised learning, concept learning, inductive bias, and decision tree learning. So what is genetic algorithm? So in the genetic algorithm are part of search techniques inspired by the biological evolution. So it is based on the Darwin theory of the search Darwin theory. They belongs to the family of scholastic optimization methods. So what is the biological terms in the sense? So we have to take the neurons. So it evaluates population of the solutions instead of working with just one solution like a traditional search. So what is the population? We have to go and discuss. So in genetic algorithm, each solution is encoded as a chromosome, often binary string. So, example, a binary string like, so we have to take 1 1 0 0 1 0. So a binary string in the sense we have to say ones and zeros. So represents possible solutions. A group of such solutions are called population. So individual we are taking chromosomes. So a group of such solutions are called population. Each chromosome quality is measured by the fitness function. We have to discuss these all in algorithm. So higher fitness gives higher fitness to the more likely to contribute to the next generations. So in a genetic algorithm, there are three types of operators are there. So the first one is the selection, the second one is the crossover, the third one is the mutation. What is the selection? What is the crossover? What is the mutation? Generally, we have to discuss number of operators are there, but main we can discuss only three operators. So these all are the selection, crossover, and mutation. So the first one is the selection. What is the selection? Selection means select the individual according to the fitness. So we have to select initiate. Next one is fitter individual have higher probability. So generally we can use in the selection process. So some common methods we are using. So rotate, tournament, and rank selection. So the next one is crossover. And what is a crossover? Crossover means recombined parts of two parents to produce the new offsprings. Means suppose here I am taking parent 1 and parent 2. So in this parent 1 I am taking 1 1 0 0 1 1 and the parent 2 is taking 1 0 1 0 1 0. So crossover, there are many types of crossovers is there. In that 1 point crossover is there, 2 point crossover is there, multiple ways crossover is there, and n type of crossovers is also there. So here I am taking 1 point crossover. What is a 1 point crossover means? We have to cross. So here 1 point means 1. So cross multiply. So what is the here? 1 1 0 0 1. So this one replaced with here and this 0 is replaced with here. So 1 1 0 0 1 0 and this is the first one and here replacement 1 0 1 0 1 0. So this is the second one. Replacement in the sense here 1 is there, that will come to the 1 0 1 0 1 1. So that is the 1 point crossover means parent 1 is 1 1 0 0 1 1 and parent 2 is 1 0 1 0 1 0. So 1 point crossover means we have to take only 1 digit. So this 1 is comes to replace to the 0. This 0 is replaced to the this place. So this is called crossover. Crossover in the sense cross we have to use. And the next one is a mutation. What is a mutation? So in this mutation, introduce the random variations by flipping bits. So flipping bits in the sense a little changes, a little random changes. So what are the changes in the sense? I am taking here 110010. So in the only one bit I am changing, one bit randomly changed in the sense if any one bit only change, that is 0 plus 1 and 1 plus 0. So here 110 is there. So in this place we have to write randomly change in the sense only one bit we can change. So then finally we will get 111 0 place we have to write 1, then after 0 10. This is called mutation. Mutation in the sense one bit changed. And the next one is, so now we will go for the algorithm. So we discussed up to now three operators. So the first one is a selection. Selection in the sense we have to select one individual, and the second one is a crossover. Crossover in the sense a little bit we have to change the bits, and the third one is the mutation. Mutation in the sense so one bit we have to randomly select and change. So what is the algorithm? Genetic algorithm. In this genetic algorithm, so the first one is the first we can initialize the population. So initialize the population, and the second one is the evaluate, and the next one is the repeat until stopping the condition. If the condition is satisfied, then we'll go for the end. If the condition is not satisfied, then we'll go for the operators. In that operators, again selection, and the next one is the so crossover, and the next one is the evaluate, and until, so if the condition is satisfied, so the process is repeat. So this is the flow chart of the genetic algorithm. So whatever we discussed, first one is the initialize. Initialize in the sense individually we have to initialize the chromosomes. Next one is the evolution, and this is called condition. Stopping criteria in the sense condition. If the condition is satisfied, if the condition is yes, then go for the best population. If the condition is not satisfied, then we'll go for the operators. In that operators also selection, crossover, and mutation. If the condition is not satisfied, means again we'll go for the evolution. After that replacement, again condition will check. This is the flow chart of the algorithm. Whatever we discussed here, algorithm, first one is the initialize, the second one is the evaluate the fitness, and the third one is the condition. If the condition satisfied, then automatically we will go for the end. If the condition is not satisfied, go for the operators. So in that operators also select, crossover, and mutation. After that, these all conditions is okay, then go for the again checking, replacement, and condition check. This is called so flowchart of the genetic algorithm. Now I am taking one example. So based on these, first what is the first one? Selection. So in this selection, initialization, I am taking here one example. What is that example means? F of function f of x equal to x square. So in that x square, the values are from 0 to 32. So I am taking 32 bit. So the values are 0 less than x less than, the x is in between 0 to 31. So 0 less than or equal to x less than or equal to 31. So here I am first, what is the first step? Initialization, the individuals. So I am taking chromosome, some values. So how to find these values in the sense, suppose I am taking 0, 1, 0, 1, 1. So what is the value of these binary bits in the sense? So initially we have to take, this is the 2 power 0, and next one is the 2 power 1, and next one is the 2 power 2 square, and next one is the 2 cube, and next one is the 2 power 4. So 2 power 0, 2 power 0 in the sense 1. So 1 into 1, so that is the value is the 1, and 2 power 1, 2 power 1 into this number. So 2 power 1 into 1 in the sense 2 plus 2 square into 0. 0 into anything equal to 0 plus 2 cube. 2 cube in the sense 8. 8 into 1, 8, and 0 into 2 power 4. 2 power 4 into 2 power 4 means 16. 16 into anything 0 into anything equal to 0. So the value of these numbers is 1 plus 2, 3, 3 plus 8, total 11. So I am taking here 1, 0, 1. 0 1 0 1 1 is 11. So like that only 1 1 1 0 0, that value is 28. So 0 0 1 0 1, that value is a 5. So 1 0 0 1 0, that value is 18. So whatever we are taking, the function is f of x equal to x square. X square means 11 square, 11 into 11 121. So 28 square, 28 into 28 784. 5 square, 5 into 5 25. 18 square, 18 into 18 324. So this is the initialization. So next one is, so second step is we'll go for the evaluate fitness function. So evaluate fitness function is the total of, so 121 plus 784 plus 25 plus 324. We have to add fitness function. The second step is to evaluate the fitness function. So we can add these all values. So we can add in the sense, totally we will get the 1254. And the third one is, if the condition is checked, directly condition is satisfied, then we'll go for the end, best population. So if the condition is not satisfied, go for the operators. In that operators, we'll go for the first one is a selection. So we have discussed already 3 ways: roulette and tournament and rank selection. So in that roulette, we'll picks parent according to the fitness. So again we have to select in this which is the best one. So which is the best one in the sense, which is the highest one. Highest one in the sense 28 is the highest one. Among these 28 and 18 is the highest one. So I am choosing parent 1 is the 28 and parent 2 is the 18. So parent 1 means 1 is the value is 28 and 10010 is the 18. So I am selecting which is the highest among this, that parent 1 is considered 1 is, and second one is the parent 2 is considering. So here I am taking parent selected in the sense 1 so 100, that is the 28. 10010 is the 18. In that, so selection, I am selecting the parent 1 and parent 2. So next one is after selection, go for the crossover. Crossover in the sense, so multiple crossovers is there. So many types of crossovers is there. So here I am choosing, so 1 point crossover at position 3. So positions in the sense, totally 5 bits is there. In that positions also we can select how many positions after in that 5 positions. So which is the, we have to take the crossover. Crossover in the sense, the parent 1 is taken as a, so 1 so 0 so next parent is a 100 so 10. Here I am considering as the at position 3. Position 3 in the sense, so this is a 3 bits after we have to draw the line. So crossover in the sense, after that this one we have to cross over. So means what we will get in the sense, so this is the parents, after crossover we will get the child. So child 1 is 11110 means crossover 3 bits after I am crossing. So 11110. Then after child 2 is 100. So 10000. So we have to find the values after crossovering. So we have to find the value. Before that, this value is 28. Parent 1 value is the 28 and parent 2 value is the 18. Now after crossovering the positions, so we will get the values. So the values are changed. So the value is a 11110 is 30. So 1000 is the 16. So we know how to find these values. So 11110 means this is the 2 power 0, this is the 2 power 1, this is the 2 power 2 square, this is called 2 cube, and this one is 2 power 4. Like that only we have to find these values also. 0 into anything equal to 0 only. 1 into 2 power 1 2 plus 2 square means 4, 2 cube means 8, 2 power 4 means 16. We have to add means we will get the 30. So like that only. So we have to find the next child also. We will get the 16 means 2 power 0, 2 power 1. So 2 square, 2 cube and 2 power 4. 0 into anything equal to 0. 2 power 4 into 1 means 2 power 4 means 16. 16 into 1 means, so we will get the 16. And the next one is the third operation is mutation. Mutation means a random mutation. So one bit we have to change. What bit we are changing? So 16 already new children we are getting. That is 1000. So that I have to in the place of one bit. So last bit I am changing, that is 10001. So that value is 17. Up to now we have to complete the mutation. Next we will go for the, so the population again we have to change. Whatever we are taking higher values 28 and 16. Now again, so the condition we will check. That condition is again we have to change the decimals. So whatever we are taking to, so 1110, that is the 30 value we are getting, and that value is square we are doing in the sense 30 square means 30 into 30 equal to 900, and 10001. So that is the value is 17. Now we are getting 17 in the place of 16. So that is 17 into 17 equal to, so 289. Why we have to do this square in the sense we are taking the function is f of x equal to x square. So next 11100, that is 28. So 28 into 28 equal to 784, and the last one is 01011, that is 11. So we are not changing. So whatever we are taking this 28 and 18, remaining values as usual we have to replace. Then we will go for the algorithm in the sense selection of first initialization, then after evaluation. If the condition is not satisfied, then we will go for the, so selection already we have to do it. So that is 28 and 18. Then after crossover, then we will get the new child. Then after mutation, one bit change. Then we'll go for the evaluation and replacement. Then we'll go for the again, so condition. So then why we have to do this all in the sense, but best fitness function we are getting, that purpose only we are doing this all. So these as usual values 11 we have to say no replacement, only we have to replace the 28 and 18. So that is the, so this is the new population. So here 30 we are taking the values is f of x equal to x square. The value is 0 less than or equal to x less than or equal to 31. So the value you are getting highest value is the 31. So population fitness function is improved because we have to add this fitness function, means we are getting more than the previous one. Whatever we are initializing, we are getting more than that. So that is so 900 plus 289 plus 784 plus 121, we are getting more only. And the next one is, so if the process is end in the sense we have to repeat the until it will get the best population value. Next generation will continue the selection, crossover, mutation. So likely best chromosome in the sense 30 we are getting, we have to replace in the sense 1111. So that value is 31 with the fitness value 31 square equal to 961, because 0 less than or equal to x less than or equal to, so 31 only. 31 in the sense the value is equal to 31, either less or otherwise equal to 31. So that is the best fitness value. So whatever we are getting the value f of x equal to x square, the value we are getting, so in the limit only, in the limit in the sense of 0 less than or equal to x less than or equal to 31. So the value is in between only, 31 square in the sense, so 961. So the value is reached, that is the best solution. The best solution, the x value is 31, and the, so maximum is f of x square equal to 961. So this is called example. And what are the applications of genetic algorithm? So where we have to use these genetic algorithm means scheduling in the sense job purpose, job shop purpose, exam timetable purpose, we have to use the genetic algorithm. And a traveling salesman problem, so we have to travel, so different places, that purpose also we have to use the genetic algorithm. And the neural network training, so neural network training in the sense in the genetic algorithm only there. So biological terms in the sense neurons, neural network training. So next one is a game playing strategy. While we are playing, so we have to use this strategy. So next one is the automated design. While we are designing, so genetic algorithm is used. And now I have to conclude my genetic algorithm topic. So genetic algorithm is based on the population. So population in the sense we have to include whatever we discussed, different types of the operators. So it is based on the population based. And the next one is the probabilistic search. Evaluate the solution using the operators selection, crossover, and mutation. So and next one is we have to use the complex optimization, problems also. And the next one is inspired by the neural evolution. Neural evolution in the sense, so based on these genetic algorithm is inspired by the Darwin theory only. In that Darwin theory, so we have to use these three operations. Based on these three operations, we can conclude this topic. Thank you.